6. We already said this yesterday, but just to remind you, we're still dealing with inequalities, only this time we're comparing two triangles in our inequalities, okay? So, I know you guys can all read, but there's not much to do on this first page, and so I'm actually going to read this one paragraph to you because it kind of explains what the hinge theorem is all about. So it says, we have seen how inequalities can be applied to sides and angles of a single triangle. Now we're going to take a look at how inequalities can be put to work between two. So take a look at this picture right here. I'm kind of covering up the answer. I should have whited this out. Do you notice that the sides are the same? Do you see how there's 1 tick mark, 2 tick marks, 2 tick marks? Do you notice, though, that the angles are not the same? So it's not side angle side. These triangles are not congruent. But wouldn't we be able to conclude that if this is the bigger angle, then the side across must be bigger? Wouldn't we be able to conclude that? Now, we don't know how many times bigger. It could be 2 times bigger. It could be 8 times bigger. All we know is it's the longer of the two pieces. You agree? In a way, that's all you're doing today. It's literally this one concept. Now, I could reverse the picture and do the same thing with sides. Okay? So you don't have to draw this on your page, but just watch mine for a second. Roughly the same triangles. Roughly the same. Okay? Let's call this 4, 4, 7, 7. Let's call this, remember, we do have to make sure we follow yesterday's rule. 7 plus 4 is 11, right? So the number I write right here cannot be bigger than 11. So how about we'll call this one a 10, and how about we'll call this one an 8? See my triangles? Okay. Is this angle, we'll call this A, and we'll call this one B. Is angle A bigger or smaller than B? Go straight across. What would you say, Ben? So you would say angle A is greater than angle B. Because if the side across from it's bigger, then the angle must be bigger. Now how much, we don't necessarily know, but we do know it's bigger. This is 2 days in a row. Okay? So this right here is the concept. They talk down here, and I don't think this is a bad diagram, but they talk about like just how, if you think about how a door works. And again, you don't have to do much with this, but I just want you to get the visual concept that if you make the door open, so if you hinge the door wider, this distance gets bigger. If the door is hinged closed more, then this distance is smaller. Okay, so just something to think about. The biggest key that you have to remember here is the sides that form the angle must be congruent. That is a huge piece of information that you have to watch for. Okay? The other big red flag, and this is not going to probably make any sense to you right now, but it will in a minute, is when you have your variable, and in this lesson they only use x, so there's no y's or any other letters, so at least they just stay consistent with one variable. You have to be very careful when x is less than. You've got to really, really watch the less than symbol. And again, this may not make a single piece of sense to you right now, but it will in a minute. Now, I guess I should say this when you're solving. Maybe I should say this. So careful when solving. because I was just about to think the next problem has a less than symbol in it and there's nothing wrong with it. It's when we solve. I think the best thing to do in this type of lesson is just for you to see what the problems look like and then ask me some questions. You got to remember that I've been doing this, again, for probably close to 28-ish years. So for me, sometimes it's sort of like, well, second nature, but I know it's new for you. So please, please ask questions when you're not sure, okay? All right, so you turn to the next page. There's sort of 3 parts. So this is part 1. I think you're going to like part 1. It's kind of nice. It's part 2 and 3 that, gets a little more challenging. So here we go. Before we start, does everybody realize that number 1 gives you all the first row, gives you all the angles? So if they give you angles, they're going to ask you about sides. If they give you sides, they're going to ask for angles. So they just reverse it, okay? So here we go. BC, EF, I'll do the first one. They're asking you how these compare. So you just kind of look across, and I'm noticing that BC has a smaller angle, which means the side is smaller. So then BC is less than, because it's across from the smaller angle. All right, so help me out here. How about Sydney? BC, I'm just staying with the directions up here. BC, is the BC one going to be greater or less than? Greater, because 95 is greater. Now that does not mean the side is 95. It just means this one side is bigger than the other side. All right, how about over here? They're still using the same letters, which I like. Christian, what are you thinking on this one?
I thought equal because they're all like the same angles.
Yeah, look at 90, 90, so it's equal. So far, so good? Let's actually skip number 4. Not that you probably couldn't do number 4, but let's just quick do 5. It says angle A and angle D. I just want you to notice, do you see how the sides are marked? So we're talking about the angle that's between the congruent legs. So we're like, all right, this is the situation. And then we just go straight across. So Brendan, what would you say here? Is A bigger or smaller?
Smaller.
It's smaller, so we need the less than symbol. Do you guys like these ones? Yeah. Okay, there's a couple of these on the test. I mean, you wish that like this was all that was on the test from this lesson. But this is like part 1 of 3. All right, A, D. Lauren, what are you thinking for this one? Correct. A is greater, so put the greater than symbol. All right, over here. A, D. Notice it's still the same marks. 1 tick mark, 2. 1, 2. So if we go across, Mary, what would you say on this one? Yeah, because we don't know what the sides are. We don't know what the numbers are. I mean, it could be an 8, it could be a 12, it could be whatever. But we know that whatever it would be the same. You like those? Good, we're good. Okay, part 2. Number 7, one would be we couldn't really 100% do this one very well because we don't know the angles here. I meant to change this before I made photocopies, and again, just getting busy with stuff I forgot. So can we alter this just a tiny bit? First of all, I did copy these out of the book, but I would much rather model what your homework looks like and what your test question looks like. So they give you the degrees. So we just need the bottom of K to be bigger. So let's call this like a 50. And how about we'll call this like a 35. It really doesn't matter what we call it. Do you see how this says 5x and 3x? again, I'm happy to do this, 5x and 3x, but when you subtract and divide, you're going to get a 0, and then it's going to look funny. So do you mind if we just add a little bit on? This is how the test question looks. Put like a plus 10 and like a minus 4. We can really put any numbers you want. I just tried to make up numbers that weren't going to give us crazy decimals, because a few in a minute are going to be decimals anyways, so let's at least start with one that's normal. Okay, so this is how the test questions look, and this is how your homework questions look. So I apologize for not having that done for you. All right. 50, 35. How do you think I could write an inequality? Avery, what are you thinking?
I don't know.
Which angle's bigger, the 50 or the 35?
The 50.
The 50. So doesn't that mean this side right here, MN, is going to be bigger?
Yeah.
So I can either write it two ways. So don't, out here. I can either do this. 5x minus 4 is bigger than 3x plus 10. I can do that way. Or I could have done 3x plus 10 is less than 5x minus 4. Wouldn't those give me the exact same answer? So which way do you like this?
Greater than.
This one? Okay. So the 50 is greater than the 35. Now just solve it. So if you move the 3 over, hold on, pause. Look up at mine. If I would not have added the 10 and the 4, do you see how this would have been a 0? It would have been kind of weird. So that's why I added the 10 and the 4, just so that it didn't come out to be a 0, because sometimes that throws people off, and I didn't want you to have like a weird one at first. So move the 4, divide by 2. If I could actually write, divide by 2. You agree with me? Is that the less than or the greater than symbol? It's greater than, so technically we're good. We don't, if it's the greater than symbol, you actually don't have to make any adjustments. It's when you come out with the less than symbol that's going to cause you a headache. And I will tell you right now, there's only 2 of these on the test, because remember, this is sort of like a large quiz. It's only 19 questions, so it's not a massive test or anything. There's one greater than symbol and one less than symbol on the test. So there's one of each that you got to be ready for, okay? All right, let's do number 8. Here's my x, which is an angle, correct? So then it's probably going to have to get paired with the other angle, because that's like the only things that would make sense. We can't put an angle inequality with the side, so it's angles together. Okay, go across. Now remember, there's 2 ways I can write this inequality down. So how about Madison? Do you want like the 32 on the left, or do you want the 32 on the right? The left? See, I would have done it the other way because I like my variable on the other side. But I'm going to do what you said. 32 on the left. That's why I like to pick on random people, because if you would let me choose, I would have put the variable, I would have done this. I like my variables on the left. But I'll do whatever you want, because it doesn't really matter one way or the other. So 32 is smaller because 4 is smaller than 6. So 32 is smaller than 4 plus 14x. You guys agree with me? Okay, let's solve this. If I subtract 4, I get 28, right? If I divide by 14, did I do my math right? I don't love reading this because in my brain, all of a sudden I see the less than symbol and I'm like, oh, you told me to be careful in those. But really, it's pronounced as 2 is less than x. But really, you're saying x must be bigger than 2. So I don't care how you write your answer, but this is still okay. Actually, it's not okay. Take a look at it. This is where I always have to stop and think. Is this okay? Think of a value bigger than 2 and plug it in. I mean, don't go crazy. Don't go like a million. Think of a value bigger than 2. Somebody give me a value. Haley, give me a value bigger than 2. 5. If I plug this in, 4 plus 14 times 5, could this potentially be a 72-degree angle? Okay, so give me another bigger number. Let's go bigger than 5. Want to go like 20s? 32. Can I have a 452-degree angle?
Yeah.
Right? So the way this is written, I have a problem because you're telling me I can pick any number I want bigger than 2, and that's not really right. I can pick 2, I can pick 3, I can pick 4, I can pick quite a few, but where do I have to stop? Say it again? I just can't hear you. Okay, so how large can this angle be? Well then, how large could this angle be?
180.
Okay, an angle itself can be 180, correct? But you can't have a 180-degree angle and be a triangle, can you? So could you be 179.9? So you could be really close to 180, but you couldn't be 180. So we need to set this so this angle cannot go above 180. So look where this is. This cannot be larger than 180. So if I was you, I think I would just like make a separate inequality. So I'm just going to draw a line. And I'm going to say that this angle cannot be over 180. Because if it exceeds 180, that kind of blows the definition of our triangle, okay? So let's solve this. Ben?
Does that mean that also that cannot be less than 90? Less than equal to 90?
Well, is that what this comes out to be? Let me quick solve this. 14x 176. What's 176 divided by 14? Ooh, not a very nice number. I'm going to round. Because I don't really think in fourth hour math class rounding that off is going to make a big deal. Look at these two. Do you see what this is telling you? It's telling you that you can pick any number bigger than 2. Now you can't pick 2 because if you pick 2, watch what happens. If this is a 6 and this is a 4, these angles cannot be the same. So it's telling me I have to pick bigger than 2, but I have to stay below this. So again, I don't want to use decimals. Let's say I pick a 12. Let's say I pick a 13. Do you kind of get the concept here? You have to stay within 2 to this, let's say 12.6 number. Now, I guess I'm okay if you guys leave your answer 2 separate inequalities, But I did not write them that way on the answer key. It's not that way on the test or anything. If you were to see a multiple choice test, you know you're going to have some. It's going to be a compound. This is the compound and. We do not have any ors. So you need to put your low number on the left, your high number, and again, if you want to round that to 12.6, but I don't think I would put 13, because it can be 13. You always point your symbols to the left. This right here is the answer, really the proper way that they're looking for it. That's like the best way. So, if they were all like part 1, it would be wonderful. But you really got to watch when you get your inequality if it fits the scenario. And that's where some people hate math. They hate it because you have to think through the different scenarios. All right, so let's look at 9. I wanted another example because honestly, those were the only 2 that the Student Journal gave us, were those front 2. And I was like, ooh, that doesn't seem like a lot to try to practice. So this was just one I found, but it does fit our scenario. So number 9 is just a different one. They're giving us, we're finding the angles, right? Here's our x. So that means we got to go with the 31. So those are the 2 numbers that are going to form our inequality. Go straight across. Now again, you just have to decide. It won't make one bit of difference, but if you ask me, I'm going to put my variable on the left, just because that's the way I like it. Michael, tell me the inequality. The 2 numbers in you highlighted yellow.
2x minus 3 is greater than
Hold. 9 is smaller than 12.
So
It'd be less than 31. So again, what you do is you pick one of the angles, you put it down, and then you look at this piece and you say, oh, 9 is smaller than 12, so that's why I use that symbol. Okay, solve it. I didn't make any mistakes in my algebra, right? Am I done? Think about the scenario. I can pick any number I want less than 17. So I can pick 10. Now remember, I want it to be smaller than 31. Okay, I can pick 6. Is it less than 31? But look at this angle degree. It's getting pretty small. What if I pick 0? You can have a negative degree of an angle. So what do I do here? Well, be careful. Let's go up here. What can this angle not be? Cannot be above 31. We already have that. So it can't be above 31. Can't be below. Okay, but we can't. The highest we can be is 30.9999 because we have to say smaller than 31. So we already have the high end.
it can't be below 1.
Well, can't we have an angle of 0.9 degrees? Might be physically impossible to draw. Yeah, we can't have an angle smaller than 0. Now, granted, if I gave you a protractor and said, draw me a 0.9 degree, you'd be like, oh, you're crazy. I don't even think I can draw a 1 degree angle, let alone a decimal. But in reality, you could have a decimal of an angle. So now you want to put the 0 on. This is not too bad to solve if you remember how to do it algebraically. But if you don't like this, we can draw a line and solve it completely separate. So if you remember how to solve compound inequalities like this, You move the 3. You divide by 2. And you have your answer. Now, I don't know that I would check my work. Give me 1 second. I don't know that I would check my work on every single homework problem because that just would be really time consuming. But watch, again, just watch for a second. If x is 1, see how it still doesn't work. If x is 1.4, see how it doesn't work. But if x is 1.6, do you see how it does work? Now again, I would not want to draw a 0.2 degree angle. That would be so difficult. But it works. So this is simply telling you the possible values that x could be. Okay, Emily.
Could you like set the angle like red times like you just said that equal to 0 because it can't be. That's what I did and I got 1.7.
Well, yes, you just don't want to use equals because then you're saying x could be 1.5 if you use the equal symbol. I mean, you're still solving it the same, like because how you move things across the equals and across the inequality symbol doesn't change. But if you put it as an equal symbol, then you're telling me 1.5 does work. And if I plug 1.5 in, then that means there is no angle. So how do I have a side of 9 if there is no angle? So you just don't want to use equal signs, but how you solve it is the same. Okay, why don't you try 10 without me? And then we got 2 story problems, which I know you love story problems. Try 10. I don't even know what the answer is, so I'm going to quick look just so I know if you're doing them right. Ooh, that's a decimal.
The first part, now you need to look at that and say to yourself, if x is less than 2, so like let's say I'm putting -5. If I put -5 in here, or here, it doesn't matter which one, would that be a realistic answer? No, you have a negative side. So then how can you make it? What values can I put? So a lot of kids will say, then if between 0, okay, but watch. If you're telling me I can pick between 0 and 2, if I pick x to be 1, if I pick x to be 1, okay, that works. And how about if I pick 20? Remove the grade and so on. Okay, what if I pick a half? I didn't remove the grade. 6 times a half plus 1. That would make this 9, right? If I do 14 times a half minus 10, I need a negative side for this triangle. So if you're telling me to pick numbers bigger than 0, I usually have to pick with a half. So you don't want to make, so this is the smaller angle, for the smaller side, right? You don't want this to be 0. I know. So just make this.
Okay, ready? The answer that many of you are going to come out with is the less than 2. You're going to come out with this. But there's another end to it because if you say x is less than 2, I don't disagree with that. But then that means I can pick any number I want smaller than 2. So if I pick 1, it holds true. Bigger angle, smaller, holds true. But what if I pick -3? How am I going to get negative sides of a triangle? So I agree with the fact that the less than 2, but what is the lowest number? So then some of you might say above 0. So you're telling me if I can pick between 0 and 2, what if I pick 0.1? Is that above 0? So if I pick 0.1, you're telling me this is going to work. You want to try 0.2, 0.3, 0.4, 0.5, 0.2? I mean, are you really going to want to sit here and just randomly pick numbers? So this is where you got to think. Look at this picture. Who's the smaller side? The 14x one? You do not want the side to be 0, do you? So then just make the side be greater than 0. Does anybody need me to show how to get to this number? Okay, so now what you need to do then is just make a separate equation, inequality, separate inequality. You don't want that to be 0, so let's call it greater than 0. You move the 10 over, you divide by 14. Ugh. We can round this, I think, for our sake. So basically what you're telling me is if I pick 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, it's not going to work. But as long as I go above this number, so like 0.78 or 0.8 or 1. Now I know that doesn't look like a large possibility, but there's a ton of decimals between them, okay? These are the challenging problems. So, again, if you probably put on your test, if you circled these two like that, I would give it to you. But I would hope, because you've already been through algebra, that you could write them together. So put your low on the left, put your high on the right, put your variable in the middle, and point your symbols to the left, and you'll be done. But again, if you don't feel comfortable putting them together, then at least get the two separate. Whew. Those are the harder ones.
So why don't you do it with the 6x plus 6?
This one?
Yeah.
Because it's the bigger angle. It's already the bigger angle. So if as long as I pick numbers that meet the requirement of the smaller angle or the smaller side, it's going to make the bigger side work too. You really only want to focus on the lowest, because if I can pick 1 for the smallest, it's going to work on the bigger one. So you don't really want to pick the bigger one, you know what I'm saying? Okay, whew, we got to get through this story problem. All right, we can get through this. This is our last part. Part 3. I think this should have probably said hikers. I guess it could be bikers. I don't know. It doesn't really matter. Read it to yourself. 2 groups of either bikers or hikers. All right, read it. Got an idea what to do? For time's sake, we don't have much time left. I'm going to try to kind of quick start. I'm going to put my camp right here. And I'm not saying your picture has to look like mine, because I see some of you drawing them maybe a little differently. I don't know. So, each group travels 2 miles and then 1.2. All right, here we go. Group A. They're going due east for 2 miles. If they keep going, they're going to just look like this. but they don't. They turn at a 45-degree angle, like that. And then they go 1.2. Now these are not remotely drawn to scale, but we don't necessarily care, okay? So this is going to be group A. All right, group B. They start due west. So they're going west for 2 miles. And if they keep going west, they would keep going like this. But it says they turn 30 degrees south. So if I was facing this way and then I turned south, it would kind of look something like that. Because 30 degrees south is not, like a straight turn. So here's my 30, and then this is 1.2. And here's group B. They're asking you how far they are from the camp. Now this might look like a complete straight line, but that's just my crummy drawing. Like that's not necessarily a straight line. Okay? If I maybe angled this 45 and 30 better. How am I going to tell which line is longer? Don't overthink it. Look up here. Which one was bigger, the 6x or the 14x? Yeah, the 6x was bigger even though 14x is bigger, right? Because of the bigger angle, correct? So who has a bigger angle right here? I heard A, I heard B. What's 180 minus 45? What's 180 minus 45? 135. What's 180 minus 30? Who has a bigger angle? B. B is further away. Not by much. It's only a 5-degree difference. They're further away. So, class, do we even need the 2 and the 1.2 miles? No. That could be like 2 million and 6 feet. I mean, those numbers are irrelevant. What you really need is the angle. Okay? Now, having said that, take a look at 12. Do you see any angles? At first, I thought, well, I'll just find the angles. I'll just see the angles, and I'll do linear pair. And whoever's bigger, then I know I've got my answer. But there's no angles. So let's take a quick look. Starting at a point 10 miles north of Crow Valley, a crow flies northeast. Does it tell me what kind of an angle to make? Okay, so let's just kind of angle it northeast-ish. And then this is 5. So I'm going to call this crow 1, just to make it easy to reference. Okay, crow 2. Another crow, 10 miles south. Flies due west. So what kind of an angle did this one turn? Yeah, they went 90 straight west for the 5 miles. So now this is crow 2. Now we can't really do linear pair, can we? But take a look at your drawing. We knew this one's 90. What is this one? What's the crow 1? It's greater than 90, isn't it? It's some type of obtuse, because if we're going northeast, we're on an angle. We're not straight. So we know this is obtuse. We don't necessarily know if it's 110, 170. We just know it's obtuse. So that means crow 1 is further away. So my plan for tomorrow